record. For the math talks, there's usually more than one way to get to that answer, and talking about those ways is going to be important for today's lesson. So, Jill, how did you know it was 99?
Because I remember my 11s.
Okay, so memorization. All right, usually in elementary school, you do your times tables up through 12, so they usually expect you to know all of those. What are some other ways we could get to 99 again without like a calculator? One time, or are you doing it like this setup? Or how are you doing it? Just like 9 times 1 and 9 times 1 and you're putting it together? Okay. That works. So it is a rule that, and it only works with single digits. So if you have single digits times 11, it basically looks like just a duplicate of the number. So like, what's 2 times 11? Or about 4 times 11. And it's that same pattern for, again, only single digits. So like 0 through 9. All right. Any other methods that you maybe did? All right, so earlier someone did this and I thought it was a good strategy. They did 9 times 10, which is 90. And because it's times 11, they just added another 9. Because multiplication is just like repeated addition, right? You add that number that many times. So it was easier for them to do 9 times 10 and then just add an extra 9 and still gives you the same answer, right? Okay. So then next one, again, don't call it out, just put your thumb up when you think you have the answer. 19 times 21. Let's try to do it again without a calculator and without scratch work if you can. Do the scratch work in your head. All right. Only see one thumb. See 2 thumbs. All right, Davin, what did you get? 399. 399. Anyone get something different? So it is 399. How did you get that, Davin? Did you do it like this?
Yeah.
Okay. So like 1 times 19 is 19. You have to put a 0 here. 2 times 9 is what? And then you carry the 1. 2 times 1 is, and then you add that, carry 1, makes it 3. And yeah, you add it and you get 399. So that you could do in your head. I believe you on that. Any other ways? All right, and you'll see why it's important to know other ways later. But like if it were me, I probably would have broken this into easier numbers, kind of like how they did over here. So it probably would have been 10 plus 9, because I know those multiples better than multiples of 19. And that still adds up to give me 19. And then 21, I probably would have done 10 plus 11. Because again, I know those multiples better than like multiples. And it is still, sorry, let's do this all over. As long as you're not breaking like any math laws, it should still work. So I could FOIL this. I mean, I could also add it and then multiply, but it was the multiplying that wasn't really that easy to do without a calculator. So I could FOIL this. What's the 10 times 10? And then the outer terms would be the 10 and 11 multiplying, we get 110. Inner terms, 9 times 10 is, And then the last term, 9 times 11 is. And then these kind of add them in a way that's easy for you. I would add these two first to get 200 plus 300 plus the 99. So then you get 399 that way too. Would you necessarily think to do it that way? Probably not. I think that is the way it's easier. And of course we use calculators in 9th grade, so that would probably be how I would get it, but it does work. So we're proving to you that FOILing with all the numbers works. All right, questions on that? Okay. So then now try this one, 99 times 101, try it without a calculator. If you've been like having no clue this whole time, try it with one of the strategies that we showed you on the side right here. So when you think you have 99 times 101, put your thumb up. Gonna pause to take a quick attendance, but still put your thumb up when you think you have. Bill, what'd you get?
9,000.
And how did you get that?
I did scratch it.
Okay, you did scratch work. Did you do it how it looks like this?
Yeah.
Okay, I mean, that's a way. You could do the scratch work in your head probably too, but since it's bigger digits, might have to write it down, but I get it. What's another way? Anyone get another way? All right, so someone told me this earlier and I was like, oh, that is kind of easier. They did 99 times 100 first. And then because it's 101, they just added another 99 to it, because 99 times 1 is 99. So what's 99 times 100? Good, and then you add 99 to it. And it is now 9,999 without having to do all the scratch work. Okay, last one, 109 times 101. When you think you have that one, put your thumb up. 109 times 100. Oh, you think you have it?
Yeah.
Okay, wait, I wanna give other people a chance. And then I'll ask for the thumb. I don't think I'll get it, but I'll know it when I see it. All right, so looking for those thumbs, put your thumb up if you think you know the last one. Michael T, what you get?
I got 1,000. No.
You can just read me the numbers and I'll take
One,
it.
one, two, three.
Okay, anyone get something other than that? Sorry, if I remember my key correctly, I think that is right. How did you get there, Michael?
I did 109 times 100 and then add the next 100.
109 times 100, and then you added an extra what?
100.
Okay, that works, because essentially what we're doing in this one is the 109 times the 1. And then of course, it's much easier to multiply by 100 than it is by 101. Because then you just kind of put the zeros on there. And since it's 101, you need to add another 109. And that is, I feel like that's right. Yes, it is. So 11,009 is the answer for that one. All right, so questions on that exercise? All right, so kind of just proves to you that you could break it up into easier numbers, and it's still true as long as you're not, breaking any math laws is what I call it. So then scrolling down, I'm gonna present this situation to you, and you and your team need to agree. So Claire claims that the sum of 10 and 3 times the difference of 10 and 3 is equivalent to 10 squared minus 3 squared. And that the sum of 20 and 1 times the difference of 20 and 1 is equivalent to 20 squared minus 1 squared. Do you agree? And then be able to justify your answer. So you and your group need to come to a consensus. Yeah, you're allowed to use calculators now, just during the math talk. I'd encourage you not to, but in the real world, most jobs you'll definitely have a calculator on you, so. Just have to be able to problem solve your way now. Yes. If your group agrees with Claire, raise your hand. So then the rest of you disagree? Okay, so River, why does your group say that, Claire is correct? So the calculator said so. What did the calculator say? Okay, so they both come out to the same number. That's usually good justification that it is going to be equivalent. Did you have anything to add? Okay. So that's a good observation. He said, because -3 squared is +9. When it's written like this without parentheses, technically you have to do the exponent first. Okay, so I agree with you there most of the time, but try to only do that if it's parentheses around it. If there's not, then really you should do the exponent first and then the subtraction. All right, so really it should be -9 for that part. But yeah, so the answer is that you should agree with her. They are equivalent. And there's a few different ways I could justify it to you. So for this first one, yeah, if they get the same answer, then they're equivalent. So what's 10 plus 3?
13.
What's 10 minus 3?
-7.
7, because
Oh, +7.
if the higher number than the lower number, like if you do like 15 minus 5, that'd be 10, but if you do 5 minus 10, that'd be -5.
All right, and then 13 times 7 is 91. And then over here, what's 10 squared? 100, but, and that's gonna be minus whatever 3 squared is, because you do the exponent before subtraction. What's 3 squared? And then what is 100 minus 9? So yeah, they both give the same answer, and it'll be true if you did the second set. They also give you the same answer. Earlier, and I like that someone brought it up that way, they foiled this, which you might think like that's some extra work that I don't need to do, but I'm going to show it to you anyway, because that'll lead you to when you can't just add the numbers, like when there's a variable involved. So what they did earlier is they foiled it, multiply the first two numbers, which are 10 and 10. And for this purpose, we're just going to leave it as 10 squared. And then multiply the outer numbers. 10 times -3, what do we get? -30. The inner numbers, 3 times 10, we get, and it's positive, so put +30. And then last numbers, the 3 and -3, really you get -9, but for this purpose, I'm going to put -3 squared so that it looks a little bit more like the one we're trying to prove it's equivalent to. And what happens with the 30s in the middle? They cancel out because they have opposite signs. So yeah, it is equivalent. We could write it as the other by foiling it out. So now decide in your groups. Number 2, using your observations from the first question, evaluate this binomial times binomial. And then show your reasoning and check your answer by computing. Do you have a question, John? Okay, so I'm gonna show you the book's explanation because I like how they put all the extra work. I feel like most normal people would just do 100 plus 5 and then in the other parentheses 100 minus 5 and multiply those together. That's like the easiest way, right? Work smarter, not harder. But if you look at the book's explanation, so this is kind of like what we wrote already on our paper. But here's also it shown in that other problem that it asked you if you agreed with Claire. Look at some similarities between the original problem. So between this one, and the one in number 2. So what's similar in each situation? There's a plus in one of the parentheses and a minus in each one. What else are we noticing about each like original problem? So the numbers that would be first, like in FOIL, are the same in each situation. All right, anything else other than Camille? What else do we notice? Is it true for the last number? Yep, so true for the last number as well. Then now look at the similarities between our answers. So these are all the final answers. This one maybe is not your final answer, but it's written in a similar format. So what are we noticing about what we boxed up in blue now? All right, in each situation, what's true? Right, table 7. So Alexa, Trenton, Darrell, what's true about what I boxed up in blue? What do they have in common?
It's like
They all have squares on the numbers, every single one. Another observation, either Alexa or Darrell, what else do they all have? They all have a minus sign in between. So notice that, and they all happen to be equivalent to whatever their pair was in red. So when you see stuff like that, these are actually what we call a difference of squares. So I would definitely write this down, star, highlight it. If you notice that you have a difference of squares, which is what would be boxed in the blue, then you can factor it according to this rule, where one of them is plus, and the other one's minus, and where a and b are the square roots of a squared and b squared. Right? Because what's opposite of squaring something? Taking the square root. So the square root of a squared is do it. It's a, because if they cancel each other out, all you're left with is the a. What's the square root of b squared? E. So if you have a difference of squares, and you'll know because what does difference mean in math? Subtraction. So if you see that you have a minus in between them, and that there's perfect squares on each side, so you should be able to type in a square root symbol, that number, and then get a whole number, or if it's a variable, something like that, or you don't get like something weird, then you can factor it according to this rule. So in this unit, and I never went through the slides with you, so let me do that right now. In this unit, we're mostly focused on solving quadratics versus last unit, we were mostly focused on graphing them. So one of the ways that we solve quadratics is by factoring. And we learned on Thursday how to factor them when a is 1. In this lesson, we're mostly focusing on when a is not 1. So that number that's in front of the x squared, you're going to see now. I'm recording right now. It'll be linked in the slides. puzzle piece will be this one, lesson 8 is what we're on. And you can expect to have a quiz whenever we finish lesson 10. So the earliest would be Thursday this week, so just make sure we're ready for that. Questions on anything I just said?
What's the final time? Or do you do them after then the meeting? Or-
So I will have it in the slides tomorrow, but yeah, we are having the binder check. The binder check's always a day before the unit test. Same with like the deadline for late work from unit 7. That'll be the day before the unit test as well. Okay, so good question. But yeah, so let's see. Back to what we were talking about. Wherever it is. All right, so difference of squares, that rules. Star, highlight it, whatever you want. But if you see that, then you can factor it like this, where one of them's a plus and a minus, and you have your square roots for the first and last of your parentheses. All right. If you need to take a picture of this, take a picture of it, but I'm gonna go to a different page. Okay. So then now number 3, now we have variables involved, which is the whole point. That's what all of this was leading up to. So we have is x plus 4 in parentheses times x minus 4 in parentheses equivalent to x squared minus 4 squared. Support your answer. You don't necessarily need to use a diagram, but however you want, be able to support your answer. So decide in your groups, are they equivalent? Yes, no, why? I'll give you 1 minute. All right, so raise your hand if your group thinks that they are equivalent. That should be like either whole groups raising their hand or we're gonna double down. Okay, raise your hand if you think they're not equivalent. All right, table 1, why do you think they're equivalent? Because it fits the equation we gave us, so it is the difference of squares. Right? Isn't there a minus sign between these? Are there perfect squares on each side of the minus sign? So I could write it according to this rule. So take the square root of x squared, that'll be the first part of your parentheses. Take the square root of 4 squared, which is just 4. And that'll be the second part, 1 plus, 1 minus. Did anyone do the math and FOIL this out? Or fill out this diagram? That's also the same as FOILing. If I use the diagram method, what goes here where my mouse is? X squared, so it's you're multiplying them. And then right here, what would go here? Down here, where my mouse is. And then down here. Good, and then if you FOILed, you would have gotten this exact same thing. What happens to the terms in the middle? They cancel because they're the same, but they have opposite signs. So that's why, and then if you simplify it to the x squared minus 4 squared, what's 4 squared? X squared class? 16. So you get the same final answer. That's another reason why they're equivalent. Now, last question I'll ask you today, and think about it before you answer, so maybe I'll give you a minute to think about it with your group. Is x plus 4 in parentheses squared equivalent to x squared plus 4 squared? Think about it, talk about it with your groups. Do you have a question, Henry? Or an answer? Okay, just wait on the answer. All right, raise your hand if you think in number 4 that it is equivalent. Raise your hand if you think it's not equivalent. All right, Emery, why?
What's the x one is going to be on the 4 and not the x.
Okay, so that is, well, you're right that they're not equivalent, so I'll tell you guys that. But the reasoning is not correct. So, who can tell me why they are not equivalent? Camille? Is it a difference of squares? No. It's not. Is this a difference? No, it's a sum. So you can't just apply this rule to it. you would have to do the math to see, are they equivalent? So first, make sure that you expand this because you can't just distribute the two, like it doesn't work that way when there's a plus in the middle. You have to remember, exponents tell you to multiply the base by itself. So write it out and then FOIL it. For time purposes, I'll go kind of fast for the FOIL. But you go first, outer, inner, and last. And do the middle terms cancel out in this one? They don't because there's no minus at all. They're all positive. So 4x plus 4x is 8x. And you get a trinomial, whereas if you simplify the other expression, what is 4 squared? 16. You get a binomial, which is not equivalent. Okay, so that's why for difference of squares, you have to have that minus so that the middle terms cancel. If you see that, then you know how to factor it out. Easily. Don't lose your notes. We'll finish them tomorrow.